Hello, devs. If you're looking to jumpstart your software development career, you've come to the right place because today we're tackling the Leetcode question, first unique character in a string. Now, for this problem, we're going to be using the unordered map, also known as a dictionary in other languages, such as Python. And this is implemented with this structure known as a hash table. So if you're familiar with any of those terms, or if you perhaps heard of them, we're going to be using that today to be able to solve our problem efficiently, specifically time complexity, linear time complexity, although we do have to sacrifice some space. Now you might be asking kind of what is an unordered map or a dictionary? Or why would it be useful actually? How do we kind of use it? It's essentially no more than like a container. It's like a list where we can go ahead and place a set of key value pairs. So say, for example, I'm selling a product. Like let's say I have my own store and I'm selling like shoes, I'm selling, pants, shirts, sweaters, and so forth. And then I also want to keep track of how many I've sold. Now let's say you want to kind of perform a find operation. You say, given this product like a shirt, I want to see exactly how many I've found. If it's an unordered list, or if it's an unordered kind of like array, then you would kind of be slow. Essentially, it's linear time because you would have to go through each, in the worst case, you would have to go through one by one and see like, is this the shirt? Nope. Is this the shirt? Nope. Maybe it's the hat. Is this the shirt? Nope. It's, the pants, up until you find the shirt. And then after, you would be able to kind of spit out what its value is, how many shirts you've sold, right? And that's kind of like the idea of a parallel array. Essentially, like let's say you have these students with certain scores. I keep them in two arrays. So like Bob and a Joe, and they have these scores 70, 80, 100. If I want to be able to find the score for any individual student, so like let's say I want to find Joe's score, I would have to iterate through my array. And then once I find Joe, then I can go ahead and look at that same index to find the score, which Joe got 100%. Now that's kind of slow. Now, if this was ordered, if this was sorted, I should say, then you could do it a little bit faster. You could do binary search, which is very nice because you would just go ahead and if you have it in sorted order, you would go ahead and just do your classic binary search algorithm to be able to find what's the index, where is that name found, and then after I could find now that I know the index, I can just go to the next array or the associated array to be able to find the score. Right, so that's log n time, which is really good. However, we could do better than that. In the best case, what we have is these sets of key value pairs. So for example, let's say we have Bob, Anna, and Joe. These you can think of as the indices. They're not really directly the indices, but just for now, just think of them as like the index. So if I go to index Bob, I can see that his score is 70. If I go to index Anna, I can see that the score is 80, and so forth. That's kind of the simple way of viewing it. But essentially your key, so this is your key, and then this is the value. What we would do is we would hash the key, which is just some kind of mathematical function. Computer science experts, they'll go ahead and create those. There are some like trivial cases where we could like say, for example, I could turn this into some kind of numeric value by just adding up the ASCII values. So capital B corresponds to some letter, I think like 66, lowercase o corresponds to some letter, and then I would just add them all up. And that would give me a numeric value. So that could be like a hash function. Not a great one, because you can see how if you kind of use that simplistic hash function, there can be a lot of cases where, like let's say a word has the same letters, it's like an anagram, then they would have the same hash. And that's really bad. So that's why we kind of leave it up to the experts to create the hash function. So we would hash it, and then that would generate a numeric, so some kind of number value. We would place it in a hash table, but that hash table is essentially like a vector, you can think of it. And we need to be able to store our value into a specific index. And so how do we get the index? Let's say if our numeric's really, really large, we just want to modulo it the size of our hash table, and then we'll go, that's our index, and then that's it. So we know exactly where to store it. Ideally, we don't want any collisions because you wouldn't want to store things in the same locations. That's where you get issues. There's lots of ways to combat that. You could do like linear probing, quadratic probing, which is essentially like if you find a collision, if you find cases where two keys map to the same index, essentially, then you could go ahead and just kind of move it to the next space over. That's linear probing. Quadratic means you move it like first the next space over, then 4 spaces over, then, or sorry, 2 spaces over, then 4 spaces over, 8 spaces over, and so forth. So you see how we're just doing it 2 to the n power. So you can do it like that, or you can use linked lists. Essentially, they call them buckets, so that if there is a collision, you just go ahead and place them in a linked list. So the structure itself is a linked list, and then it's chained with linked lists. That's another way to do it. It's just kind of different implementations, but that's in a nutshell what the unordered map is, and or what a dictionary is. And the reason why we're using it is just because we're able to find it so quickly. This is going to be constant time to be able to find, given a key, to find its corresponding value. So if I want to find Bob's score, I can do it in constant time. Versus if I do it with parallel arrays where it's not sorted, that's going to be linear. And if they were sorted and I use bin search to be able to find it, that would be log n. So it just depends on how fast you want it to be. It doesn't have to be that fast, but ideally, if we want to optimize things, you could use that. So let's go back to the problem now that we kind of got a little bit of a run through of what an unordered map is or a dictionary is. I'll have probably another video on it that describes it in better detail, but for now, let's see what it's asking of us. So given a string s, so just some kind of string, find the first non-repeating character in it and return its index. If it does not exist, return -1. Okay, so essentially we're given any kind of word, and the first character that's not repeating or doesn't have like a double or triple or so forth, then we're just going to go ahead and return that index. So if we look at this example test case, we see Leetcode. Leetcode has a number of different letters that are not repeating, like the L, the T doesn't repeat, the C doesn't repeat, the O doesn't repeat, and so forth and so forth. But the first one that doesn't repeat, assuming that we're iterating through it from left to right, is the letter L. Right? So L doesn't repeat. And what index is that located at? Index 0. So that's kind of what it's asking us. Next up, if I look at love Leetcode, what's the first index, or what's the index of the first character that does not repeat? So if we look at L does repeat. If we look at O, that one repeats here as well. If we look at V, that one doesn't repeat, so that's why we get index 2. And now if we look at another string where all of the characters within our string do repeat, so AA, BB, there's no character in here that's unique. And so for that case, we're going to go ahead and return -1, right? So if you don't find any that are unique, then you go ahead and just return the index -1, just a flag to say we didn't find any unique values. Now, that being said, let's go ahead and go through the logic for it. Now, I want to preface this by saying our time complexity for this is going to be linear, just because we're only going to have to go through our word twice. The first time it's going to be to create our map, and then the second time it's going to be to see if there's any unique values. So that's essentially we're going to search through our word twice, and for that reason, it's going to be 2n, but we drop the constant, so it's linear time. Space complexity, we're going to use a map. So essentially, just think of it as like a vector on the side that's really efficient for finding key value pairs. So that's going to sacrifice some space. That's why it's not linear, but instead, that's why it's not constant space, but linear space, using this unordered map / dictionary. And once again, I just want to stress the reason why we do it is because the find on average is constant time. So it's really, really fast. An alternative to this solution, which we won't be discussing in this problem, but we could do it probably in like another video. This one's pretty straightforward. We could just sort the string. And if you have actually, let me remove this. You don't want to do this because you can sort it now that I think about it. And you could find the first, well, it's going to mess up the order. So actually this is not a valid solution. So let me go ahead and get rid of that. I apologize. So that's not a valid solution. So this is the way to go for, at least for now. There is a brute force solution where we could just use constant space, but we would have to have time complexity of O of n squared, just because we'd have to go through for each character within our string, we'd have to search each other character within our string, which is not the right way to go. So that one, I could cover it a little bit later, but you've probably seen those brute force cases in other circumstances. So I'll kind of think about going over that one. But let's continue. So the first thing we want to do is we want to iterate through our string. So like, let's say, for example, Leetcode. And we want to consider, as we're going through each character, if the letter is not within our map, we want it to be within our map. Now, what's our map going to be composed of? Our map is going to be composed of two types. It's going to be the letter, right? So the letter that we found, such as like L, and then also the count. So it's going to be an int. And that's really because for each letter, we want to keep track of how many times we've seen it, also known as the count. So you can think of it as like kind of like letter count. Okay, so for each letter, we're going to have a corresponding count. That's the key value pair that we're going to keep track of. So if it's not in our map, insert it within our map, insert that letter. So the letter is going to be the key and have it have a count starting with 1. Now, what if the letter is within our map? So say, for example, the first time I see the E, I'm going to insert it with the count of 1. That makes sense. But what if I see this next E? Well, I've already seen it before. It's already in my map. So then I would increment its count by 1. So now I've not only seen it 1 time, but 2 times. So that's how we kind of keep track of that. And we just go through it from start to finish. And by the end, we'll have a count of each letter. Next up is once we have our map completed, so we have each letter mapped to a specific count, we'll go ahead and iterate through the string again. And we're going to take a look at the L, and we're going to search for its count. So if I find that its count is 1, then I know that it was unique because my map already kept track of all the counts, the first time. So if its count is 1, I found the unique letter, I can go ahead and return that index. Simple as that. Now, if it's not a 1, then I just go ahead and go to the next element, and so forth and so forth. But let's say, for example, I make it through all of the elements, and at no point do I ever find there to be an element a key with a count of 1. Let's say all of them are greater than 1. So that means that none of them were unique, right? So at that point, they were all duplicates. So whether they were doubles, triples, doesn't really matter. We just know that it's not unique. So that's where we return the flag -1. And that's really the logic behind it. It's a pretty straightforward problem, I would say. But let's look at it in action on Visual Studio, just to kind of be able to go through it. We're going to code this ourselves again, but I just kind of want to show you the kind of like the general structure. So this is how we create our map. And once again, our key is going to be each letter that we have within our string. And then the value is going to be the count associated with that letter. So like the L in Leetcode, it's going to have a count of 1. The E within Leetcode is going to have a count of 3, and so forth and so forth. Here's our word. I'm not doing this within a function. I'm just using this within main to keep it simple. And what we want to do is after we set up our map and we know what our word is, we're going to go ahead and iterate through our word. Iterate through it, and we're going to use an iterator to be able to locate. We're going to use, how should I phrase this? What we want to do is we want to check if the element is within our map, right? So we have this map that's empty at the moment initially, and when we go through this loop, we're going to go through each character within our string, and we're going to attempt to find each letter within our map. So there's 2 possibilities. Number 1, if it's not within our map, then what we're going to do is we're going to insert it within our map for that letter and then the count of 1, just like we said before, right? If we don't find it, or if we do find it within our map, then what we would want to do is we want to increment its count by 1, right? So this is the count. This is just another way of saying it. This is the name of the map. And then for the given key, we want to increment its value. Yeah, that's really it. It's pretty straightforward as far as creating the map. The reason why I hesitated was because it mentioned iterators. Just think of when we use the find function, it doesn't necessarily return to us an index, but it returns to us an iterator, which is a pointer really behind the scenes. And that's a memory address within our container, with the exception of the end, whatever the end method returns, because that's always technically outside of the container. But just think of it as an iterator just being like kind of like an index. There's a little bit of an extra step that goes on, but essentially, if the index is located within the container, then I know that it was found, right? So then I know that it was found. But if the end, which is not technically the end of your container, but it's one past the container, then you know that you didn't find it. And that's just a little bit of the syntax within C++. I just don't want people to be freaked out with kind of this syntax. Also, if this kind of makes you feel concerned, you could just write auto, and that'll go ahead and type deduce the correct type that you need. A lot of times you see iterators being replaced, or kind of types being replaced with auto when they're extremely long, just because they can get, scarily long. But anyways, after we create our map, so our map is finished. What we want to do is we want to go through and show all the values within our map. Actually, let's just run it from here, right here to here. There we go. So what we want to show is that I'm going to iterate through my map called letters. I'm going to go through each key value pair, and I'm going to print out the key and then print out the value. So just behind the scenes, know that really so every time we insert something within our map, it's really just a pair, specifically a pair of char int. And so if I hover over it, you can see that this data type is really just a pair of const chart and int. So the key is immutable, but the value is mutable. The integer is mutable in this case. So if we go ahead and print this out, you can see that, let's run it. You can see that we, when we mapped our string Leetcode, you get the letter L, which has the value 1. You get the letter E, which has the value 3. And so you can see that each of our keys are really just the letters, and then our counts are the values. So I thought this was kind of a nice example to be able to kind of check through them. But that being said, the next thing we want to do, aside from visualizing this, which is kind of the reason I wanted to show this, was we want to be able to, after visualizing our map, we want to see which one is the unique character. So the way we do that is we have to go through our string again. And the reason being is because, as you saw, we created the map, but there can be multiple instances where the count is 1. So which of them came first? Is it the L that came first in Leetcode? Is it the T that came first in Leetcode? Which one came first? And so for that reason, we have to iterate again, one by one. We get its count for the current letter. And if the current letter has a count of 1, then we know that was the first unique letter, and we can break out. Right. So if I run it once more, you can see that now it runs. And this time we're not returning the index, but we're just returning the letter. So you can see in this case, it's returning the letter L, right? The lowercase L, but L. Now, I do want to mention that this problem does treat lowercase letters and uppercase letters differently, just because they have different ASCII values. So just to kind of prove that, if I write Leetcode and run it, you can see that it distinguishes lowercase e and uppercase e. Lowercase e is 3, uppercase e is 1. So that's just something to kind of keep track of. But that's really the method in which we're going to find it. Now let's go ahead and code it ourselves. So what we're going to do is, should we code it in Visual Studio? No, let's code it. Let's code it here. Yeah, that's fine. Let's go to here. So let's go back to Leetcode. The first thing I want you to note is that in order to kind of write pairs, that you're going to use the utility class. As you saw, we're going to use iterators to use the find function. That's going to return an iterator. So that's why we have that there. And then additionally, we use unordered map, which is our dictionary. All right, so dictionary, and this is to have an associative container for key value pairs, right? Key value pairs. And then the find is on average constant time. There we go. So just wanted to make sure you understand why I'm including those libraries. I don't want to be like the stereotypical C++ programmer that includes just like sets of libraries without really having a need for them. So that's just something I wanted to show. Now let's go ahead and start off by creating our container. So here we have an unordered map, which maps a letter to a count, so a char to an int, and we're going to call it letters. So here, let's say this is our map. map for a letter to a count. Okay. Next up, we're gonna have to iterate through our string to create the map, right? So based off of the string, just like we saw in our previous example, the way we do that is let's iterate for each letter within our word. What I want to do is I want to create, actually, let's just use an iterator here, because if I were to write the iterator, no, actually, let's not be lazy. That's fine. So we're going to have an unordered map iterator, unordered map of type char int iterator. There we go. I'm going to call it found index, so where we find it. And so the way we return that iterator is for the map's name, we're going to use the find function, and we're going to try to find this letter. So essentially, within our map, we're going to try to find the current letter. And there's two possibilities. It can either return end. So let's see, letters end, which means it was not found. And if it doesn't return that, then it means it was found. So that's going to help our logic later. So try to locate letter within, how should I say, try to locate the letter within the map. There we go. So if found index is equal to letters.end, so if it was not found, we need to insert into our map. And the way we insert is we just use our map, insert, and there's two ways you can do it. You can actually create it as a pair, and then, so you could use the pair constructor to insert it, or you can use like pair initialization, I believe. Essentially, you use the curly braces to initialize it, and it'll from then create, so it'll create the object, and then from there it'll use the it'll implicitly convert it to a pair. So we could do something like this. So here we want to insert the current letter. Since we haven't found it, we want to insert that letter, and we want to say that since we haven't found it, it should start with a count of 1. So insert the letter within our map with a count of 1. And that's because it's the first time we've seen it. If we have seen it before, so we did find it within our map, found within map, we want to increment its count. So how do I find it? So within our map, we want to go to we know what the key is. The key is going to be the letter. So here is going to be our letter, and then this gives us the count. So this is equivalent. So when you have a map and you index it to the key value, then this gives us the count. And the way we can increment that is we just write plus plus, right? I could do it that way. There's other ways we can go about it. I think I have a TikTok short or like a YouTube short on how to increment by 1 in 4 different ways. But this is just one way to go about it. So we just want to increment for the given key. There we go. And that's really it. That's all we're going to do to be able to create our map of the string. Next up, we want to iterate through the string again to find the first unique character. Okay. This time, however, since we are going to return the index, we can't use a for each loop. We want to use a standard for loop, just because we need to keep track of the index. So we're going to say for int index equals 0, index is less than, my string is called word. Index. Okay. What we want to do is we want to see, okay, so what's the letter that we're currently working with? Because we're going through the string, so we don't have the luxury of being able to say like this is the current letter. We'll create that ourselves. So the current letter is really just word at the given index. This is just for convenience, so we don't have to write things kind of in a really like elongated manner. The next thing we want to find is what's the count. So this gives us the current letter, Now we need to find its count for that letter. So what's the count? What next? What is the count for that letter? So the way we do that is we use the name of our map, which is called letters. We index it to the current letter, and then this is our count, right? So this is our count. We want to stick that in some kind of variable. So this is our current count is equal to this value. There we go. Next up, we want to check if the count is 1, then we know we have a unique character. We have a count of 1, so it doesn't really repeat. And since we're iterating through it from start to finish, we're going to be able to, the first time we find that case where we have a count of 1, we know that that's the first unique character. So if my current count is equal to 1, this is the a unique character. What we want to do is we want to return the index where we found it. So that's really it. So return index where we found the first unique letter, unique character. But what if we go through the entire word and at no point is the current count 1? So we go through and each one has a count of 2, 3, 4, 5, and so forth. We don't really need to check lower values just because we started off with the count of 1. So there's going to be no instances where we're going to have a value of less than 1. But so if it's not 1, we know that it's greater than 1. If we go through each single character and we don't get 1, then we know that they're all duplicates. At that point, we just want to, if all are duplicates, because current count exceeded 1 for all cases, then we just want to be able to return the flag -1 according to the problem. And that's really it. That's kind of the solution for this problem. It's kind of nice just because it's pretty fast. And it's faster than the brute force method, and it kind of shows us a little bit about how to use maps. Maps are used very commonly in Leetcode solutions. This is the first time we kind of covered it, so I just took a bit longer to do so. But I really hope you did enjoy the overview and kind of the detailed explanation, albeit sometimes a little bit longer than normal. But thank you so much for watching. I really appreciate you watching. Please like, share, and subscribe if you feel like you're one step closer now to becoming a better software developer. And I hope to see you soon.